Hi folks, so coming to the finish line with this Sansui 9090 dB. Today we're going to be going through the radio alignment, and I'm going to be deviating significantly from what's in the service manual, and the reason for that is the service manual was written back before a lot of the test equipment that I have available to me was either affordable or even existed. Now, there are those who go to purchase what they see in the manual, so it's driven up the prices of the sound technology ST1000A or the Sencor SG165 far above what they should really go for in today's market. Interestingly, even though they didn't have them back in the day, everybody's perfectly fine with using a digital multimeter on this. But the moral of this story is you don't need vintage test equipment to service or align vintage audio equipment. And since most of what I have on my bench here far exceeds the specifications or abilities of the test equipment back in the day, that's what we're going to do. And one of the things that they specify in the manual is the use of a, the term's eluding me right now. Oh, sorry, genoscope. Okay, a genoscope is basically just a combination of a sweep generator and an oscilloscope. And there's no real need to sweep tuners like this that have ceramic filters. Sweeping is a lot more desirable when you're aligning a tuner that has multiple IF stages with individual adjustments. This doesn't, so as we go through each process, I'll outline what they want in the manual and what we're going to do instead. So let's get to it. Okay, so before I do anything here, I want to just outline how I have the signal generator connected to the receiver, and I'm just going to put in a very small signal and check the sensitivity of our front end before I make any adjustments. So I have the tuner set down to the base of the FM band. We will set our generator to 87.5 megahertz. And we are going to set our amplitude to 5 microvolts. Now, if you notice, the scope is now showing nothing. The scope is connected to one of the tape outputs on the back of the receiver. If I turn the RF off, you can see we have static on the scope. And if we turn the RF on, we don't. And that's at 5 microvolts. I'm going to drop that to 3 microvolts. And we have just a little bit of static, 2 microvolts. So I'm going to go back to 5, and we're going to turn the FM on. Our FM is going to be set to 75 kilohertz of deviation. That corresponds to 100% modulation of an FM signal. As you can see, we have a sine wave on the scope. It's not the prettiest thing I've ever seen. As we tune it, we see we have a pretty nice looking sine wave at 5 microvolts, which is a very small signal. So if I drop it to 2, let me go to amplitude, 2 microvolts, we still have a recognizable sine wave. There's a lot of static in it, but our front end is very sensitive. So this tuner should benefit from any alignment. That's 3 microvolts. And it may not need a lot. This unit was well cared for. When I opened it up, there was no dust inside. The owner is obviously not a smoker because I smell no tar inside of this. Obviously a pretty good housekeeper too because of the lack of dust. So it was well cared for. I don't think I found more than 1 or 2 capacitors that had drifted significantly. So I think this is not going to need a lot of adjustment, but I'm going to go through and show you what we're going to do. And since I have at my disposal a spectrum analyzer, that's the tool I'm going to use. A shop back in the day would have never dreamed of being able to afford a spectrum analyzer. They're prohibitively expensive, and there wasn't a shop anywhere that had one. But how we are decades later, and they're quite affordable, so that's what we're going to use today. So the first thing they want us to do is they want us to adjust the IF. Now, they want us to go and test the IF coming out here, and they want us to inject the signal directly into the tuner. I'm going to leave it connected directly into the antenna. This should work fine. And by the way, my generator is connected, a coax cable going to my L network. This is a network I made. It's nothing more than a coil of copper wire and with a small capacitor on there to flatten it out, and it matches 50 ohms to 75 ohms, and that's going directly into the antenna through one of these guys. Anyone who's ever had cable TV knows what these are. These are what they call matching transformers or balance. So that's how we're getting our signal in. I have my probe connected down here, and this is considered to be test point 1 on the IF multiplex board. And we are going to put in an unmodulated signal. Now let me set the spectrum analyzer up. So we're looking at the IF. IF for FM is 10.7 megahertz. And our span, we're going to set at 1 megahertz. We don't really see anything there, so I'm going to turn the modulation off. And turn on the power supply for the active probe I'm using. Now we see we have a little spike on our spectrum analyzer right about here. If I turn the modulation on, you can't really pick it out because of the modulation. So I'm going to turn the FM off. And now we can see we have a little bit of a spike there. I'm going to put our amplitude back up to 5 microvolts. And you can see right about here is the spike we're going to be adjusting. Now they tell us to adjust LO5 in the tuner module, and that is this guy right here. So I'm going to put this back on the spectrum analyzer so we can see how much of an adjustment we need here. Again, this unit was in pretty good shape, so I really don't think there's going to be a lot to be gained. Okay, that drops it. We just want to peak this. That's all they say in the manual, just peak this. Okay, so right about there is the most we're going to get out of it. I'm going to turn the gain up on the generator. Okay, that's 10 microvolts. You don't really want a lot of signal in here. You don't want to trigger the automatic level control. You can see that's right about peak. Back to 3 microvolts, and that's going to be hard to see, but it's still there. That looks like about as good as we're going to get that. Okay, like I said, I don't think there's going to be a whole lot to be gained because this unit is very sensitive and it's in very good shape. All right, so the manual wants us to use our genoscope. It tells us a level. It doesn't tell us any kind of frequency. It may be set. I've never seen one. It's an antiquated piece of test equipment, and like I said, nowhere near the quality, accuracy, or repeatability that you get with some of the test equipment I have on my bench. My signal generators are all clocked externally from GPS, and this means I never have to worry about them being calibrated for time. It's going to be rock solid. Okay, so now the next thing they want us to do is they want us to look at test point 1 over here. And we're going to have to adjust the spectrum analyzer quite a bit. We're going to set our span to, let's try 2 megahertz. That looks a little more like a peak. And now we want to adjust the IF transformer. That's the last transformer in the IF stage. And again, they just want us to peak this. Okay, that's dropping. That's peaking. So you can see we go right through that point where we get maximum output. We want the maximum output. And that is right there. Not maximum. Not maximum. And just like the 3 bears, that's just right there. Now I want to take a moment and talk about alignment tools. It seems like no matter how many you buy, you never have the right one. I've bought a bunch of them, and just to give you an idea, I'm going to open the drawer where I have my alignment tools, just to give you an idea of how many there are. These are all nothing but alignment tools. Some of them I got back in the day when I was working on TVs, analog TVs and VCRs. Some of them I purchased when I got more into radio alignment, but no matter how many you have, it's really difficult to get the one you need. And I just threw those back in the drawer. I wish I hadn't, because you have to go through there and find the right ones, but I believe those are them. Well, anyway, so those are the first two adjustments. And that's how we do that. Okay, the next step, they want us to adjust the muting coil, and the first problem I came up with is the muting coil test point is test point 4, which I don't find anywhere. And when I check the circuit board layout and compare it to the pictorial where it shows where the test points are, it doesn't match up. So this is where I had to poke around at the schematic, and it looks like what they want us to do, or what we'll be able to do, is we can look at the anode of D08 and adjust it for a peak, because this is also something they want adjusted for a peak. So if I look at the anode there, and we look at the spectrum analyzer, try to keep my big head out of the way here. Okay, you can see it goes right off the screen. So let's go to amplitude and drop our reference level 20 dB. Okay, that's a little more acceptable. And now we want to adjust this also for a peak. That's too low. Okay, and that is just right. Right about there. So that's our peak output. You really need to have an idea how these circuits work, how to understand a schematic. It's not unusual at all to find errors and omissions in service literature for vintage equipment. And it's up to the technician to understand that and make sure that he is or she is doing the right thing. Now, you can also go on the internet, which is, there's nothing wrong with that, do a search. Somebody has probably gone down this path before, and chances are good that they have put something on the net for you to look at. But having an understanding of what you're doing is paramount. That understanding will help you when you find yourself in situations like we just did now. Next item on the list here is they want us to adjust the discriminator, and that's right at the end of the FMIF before we go into the multiplex stage. And they want you to put in a signal and adjust for an S-curve. We're not doing that either. It's much easier for us to adjust the discriminator simply by making sure we have no signal in, and to that end I have taken, I'm going to go handheld for just a moment here, try not to get seasick. And what I've done here is I have pulled the antenna lead off and shorted it with an alligator clip to ground, because we want no signal in as we just adjust the discriminator. And what we do is, once we have no signal in, we want to make sure that the tuning meter is centered. So if you look at the tuning meter, and let me try and get you straight on here so you can see that. Then all we want to do is adjust that to make sure that it's centered. And of course I don't have the right tool in my hand, so let's see, this should be us. And you can see by turning that transformer we can go around center there. We want that dead right in the middle under a no signal condition. And that's a much easier way to set your discriminator. And as I said, Marantz uses this. We don't have to worry about sweeping, getting an S-curve, making sure everything's right. If you have the equipment, you're more comfortable with that, there's nothing wrong with it, but it's really not necessary. Our discriminator, actually the discriminator was off a little bit, I must confess. Before I talked to the owner, I was just going to line this off camera, put it together, test it and send it back because I feel bad. I've had it over a month. I don't like having other people's equipment for a long period of time. And in the vintage auto repair world, while a month is not a lot, I just don't like having other people's things in my possession. So, enough of that. Now we're going to move on and see what they want next. Okay, so the next thing they're going to want from us is they want the distortion touched up. So for that we need to turn our modulation back on and we need a good strong signal. And the manuals usually recommend 1 kilo microvolt, which in the real world is known as 1 millivolt. 1000 microvolts, 1 millivolt. So we set the amplitude on the generator for 1 millivolt. You see we have a really nice solid sine wave. And we're going to use the Keithley's distortion function to see how low we can get that. So our THD on the meter is accessed by hitting the shift key in AC volts. And that puts us into THD mode. We take the lead from the scope and put it in here and see what we get. So we have 0.3%, so we'll see if we can get that any better. This is a nice little distortion analyzer. The Achilles heel is the signal generator within it. I didn't know that when I bought it. To get down into the really low levels, you need a better signal generator, which is why I wound up spending an obscene amount of money on that. But anyway, for this we're going to adjust TO2. It says 1 and 3, but we adjusted those in another step. So let's see what this does for us or to us. All right. Okay, so about 0.28% looks like about as good as that's going to get. And I was all these have been very small adjustments. This unit is in excellent shape, and the owner just wanted it repaired and refurbed, so it'll be good for decades to come. And this should do it. Okay, so that's about as good as we're going to get there. Folks, unless somebody has been into these and twiddled these adjustments, you really shouldn't need to adjust these very much at all. If you do, you may be doing something wrong. When we're adjusting anything in the front end pack here, we use very, very low signals, vanishingly low, usually in the range of 3 to 5 microvolts. When I went to adjust the Marantz 2265B I was working on, I discovered that it had very poor sensitivity, which turned out to be an RF amplifier FET in the front end. I replaced that and it dramatically increased the gain and straighten out the problems I was having with it. When you started making other adjustments, you usually need a much stronger signal. So they want you to start here, work your way back. And we're also going to be doing the dial alignment, and you want low levels for that as well. So let's see what the manual has us do next. Okay, so now we're setting the dial tracking. And according to the manual here, we need to set it between 90 and 106 megahertz. And we adjust these points here, LO6 and TCO4. So those are on top of what they refer to as the tuner pack, LO6, TCO4. And what I like about this generator, you're not going to get with the sound technology or the Sencore, is we can set up our increment and decrement buttons. So we want to go between 90 and 106 megahertz. So we set frequency, increment set 16 megahertz. Now these increment and decrement arrows will take us between the 2 points. Because this is an iterative process, we have to do it several times to get the dial tracking to fall in. So I just hit the generator like this. 90, 106, 90, 106. Okay, so we're going to watch the scope. And we're at 90 megahertz on the dial, and that looks, believe it or not, pretty good. So now we go up to 106. So we're 106 on the dial, and we hit the increment arrow, and now we have to adjust TCO for 4. And this is a really touchy adjustment. You'll see that as I start to adjust it. Okay, and you want equal tearing at the top and bottom. Okay, we need to use really low signals to get this. So we want equal tearing at the top or bottom. By tearing, I mean this jitter up in here. Really hard to get on this end of the dial. That's about it. And now we go back to 90. Sometimes, depending on how flat your L network is, you may have to adjust the amplitudes. Let's see. Okay, I'm at 5 microvolts here. You got to have it right down in the dirt in order for this to be accurate. All right, now we go back to 106. What this does, it aligns the dial so everything falls where it's supposed to. Okay, we're at 106, so we got to dial our TC104. Okay, and there we are. And it doesn't help that right around here are a couple of radio stations. There's our sine wave, and a little bit one way. Got a radio station there, another one there, here's us, and there's one right there. And that's what we have to deal with. Just to give you an idea of what it's like out here, or where I live, there's a great website called fmfool.com. And you can put your address in, it'll tell you what radio stations you should be able to pick up in your area. And if you look at this list, you'll see that we have a heck of a lot of radio stations I should be able to get right here. So even without an antenna hooked directly in my generator, I got quite a bit of interference to deal with. I've toyed with the idea of trying to shield the garage a little better. Like all the other projects, maybe someday I will. But anyhow, this is what, as I said, an iterative process. We go through it several times, and eventually it falls in. So I'm going to do this one more time on camera, then I'll finish it off camera, because sometimes you have to go through this many times to get it to fall in right. And I don't like to have long form videos, as you know. Okay, so that looks pretty good there. We want equal tearing. Okay, and go back up to 106. All right, and that's looking pretty good there. Okay, I'm going to pause the camera, do this a few more times, and we'll see how well it falls in. Okay, so I did it a few more times, and we are right on 106 here. And if you look at the scope, you can see we have a pretty decent looking sine wave. And now I'm going to take us back down to 90. And that is right on 90 right here. Okay, there may be a little bit of parallax error because you're on a bit of an angle, but that is 90. And if we go back and look at our scope and we drop the generator to 90, you can see we're looking pretty good. So that should help all the stations fall into proper places on the dial. That's the whole function of this. By aligning both ends, everything should fall right into place. Okay, so they want us to do a 90 megahertz RF adjustment and 106 megahertz RF adjustment. So where are we at now? We're at 90, so we're going to do that. Okay, so we're going to do the RF adjustment for the 90 megahertz, and they want us to turn L1, L2, or L3. That's LO1, LO2, LO3, and most of these don't make a huge difference. I generally just check them to make sure they're good. You want to have a really low signal in. So let's okay. Okay, that looks pretty good. And then 3. Okay. A little more signal. Okay. Okay. That's about as good as that's going to get. Okay, and then we go to 106. Now these we adjust the capacitors. Rule of thumb you have is you adjust capacitors for the high end, you do slugs for the low end. Okay, so now for this they want us to do TCO1, TCO2, TCO3. Okay, that's about as good as that's going to get as well. Okay, next thing they want us to do is signal meter volume. Now they tell you they want 100 dB. I believe what we're going to want is 1 millivolt. If we look at our signal level, it's supposed to be around 4.7. And if we look at this guy right here, we are, let's see here. Oh, what did they want for 98 megahertz? Okay, so, oh, I got a strong radio station right there at 98. So we're going to go to 97 megahertz. And we are going to, let's see. There's 97, and that says about 3. They want us to adjust VRO2. Okay, VRO2. This guy. Okay, that's about good. It's really an arbitrary measurement, so we're not going to worry about that. Okay, going to pause this for a moment. Okay, so now they want us to align the phase lock loop for the FM. The test point was not visible. It's not marked as a test point on there, but by looking at the schematic and seeing it was the joint of these 2 resistors, I saw a point on the board where 2 resistors were soldered together, and I just put my scope probe there, and I get pretty much what I need to get. Now, they tell us to ground test point 3, and that will unlock the VCO. So if I pull the ground clip off, you'll see it goes to 76 kilohertz right on, but they want us to set it to 76 kilohertz, give or take 200 hertz, by adjusting VR4. Now, I can tell you from doing this on other receivers, It's a little touchy to get it right there, but we're going to get it as close as we can. So if we get it, let's see. Wow, okay. Okay, I'm just going to scrub this pot a little bit. Probably hasn't been moved in 30, 40 years. Okay, so we want 76 kilohertz. All right, let me ground that again. I'm going to make sure we get this right. I may change to the active probe. Yeah, let's do that. I'm going to change and use the active probe I was using on the spectrum analyzer. Okay, so I'm using the active probe, and let's see. Yeah, it looks pretty good. Okay. So yeah, that times 10 probe didn't play well with this. It's a pretty low output signal. I didn't want to swamp it, but that's where having an active probe comes in handy. This is a Tektronix, and of course I don't remember off the top of my head, but it's a P6102 active probe. I had to get a power supply for it because this scope, newer scopes don't have the power jack on them like some of the older ones do. I think the 485 has them on the back, but I picked this guy up for about 40 bucks, I think, on the auction site. So, what do we got next here? Okay, so we need to get our separation. Okay, that's VR5. Now, I'm going to cycle through. This is a mono signal. And if I go to right minus left, you see now we're 180 degrees out of phase. If I go to right only, we have a right signal. It's crawling across the screen because I'm triggering off the left channel. I trigger off channel 2, it goes stable. And if I go to left only, we have a good stable display and nothing on the right. So what we want to do is we want maximum separation. The separation looks pretty good. I'm going to turn up the gain here. And we are going to see about VR5. Okay, that's about as good as that'll get. Let's try right only. Okay. I'll trigger off the right channel. Yeah, that's pretty good. So our separation looks good. Looks pretty good for the multiplex. I'm going to hook an antenna up and we'll see what we get. I can't land on too many stations, but I may try to modulate my generator and play some YouTube safe music through it. Okay. It's not going to be stereo because I don't have a way of modulating it in stereo. Yeah, I'm about to fade away. Well, this is our FM. I have no antenna hooked up. That's directly out the generator. Okay, I'm going to hook up an antenna. We'll see what else we can get. An antenna hooked up here. I can't land on A stations too long or I will run into afoul of YouTube's copyright issues. But
fit into one of the letters, they're let alone, and they're not.
5 for me.
5 out of 5.
Il parlait de Toussaint l'ouverture.
Slow the percussion.
Crash, slip or fall, call Freeman Injury Law. Get all the money you deserve.
My location, Lost Surprise Labs. Exclusions apply. See Rose.com for details.
And out with the ball. You've got one fewer.
Okay, got a little YouTube safe music playing through here. This is in the aux port. This thing sounds really nice. Now, it's really hard to get an idea of sound quality through this little lapel mic I'm wearing, but even with the tone controls flat and my small bench speakers, this thing sounds really good. Now, I'm going to put it all back together and bring it in the house and run it for several days to a week to make sure no problems crop up. I'll probably leave it on overnight once just to make sure before I go shipping it back. Wow. Really sharp and clear. Again, tone control is flat. I'm sure this thing would put stretch marks on my bench woofers if I cranked it up even a little ways. Anyhow, I'm going to stop this video because it's already run on too long. I thank everyone for watching, and as always, I like giving back to the community that's given me so much. Thanks a lot, folks.